Good morning to all. Today we are going to discuss about um, class diagram with method level modularization as well as class level modularization and package level modularizations. So first you see about the method level modularization, then later you can see about the class level and as well as package level. First we see about the class diagram, how to draw class diagram about the method level modularizations. First you have to draw the package diagram. So I want to draw first packages here. Let's take a simple packages. Now this package name I want to create with captions. So let's create a package name. So I can use any name as a package name here. This user defined packages. Let's take a package name as a P1, and inside the packages we want to create our classes. So this is the class diagram. I'm going to draw the class diagram here. This is the classes. Now this class diagram contains three different compartments. The first part is called as class name. We have to write a class name here. Then remaining parts we have to write as instance number and methods. We have to write as instance number and methods. Then last part is we can write as methods here. Now I want to write a class name here. We'll take a class name here as a cuboid. So I'm writing some here. Example name as cuboid here. These are class names. So let's increase size here. So this is our class name cuboid. Then I want to add my variable names. That is here I'm going to create all the variable name as static variables. We see about the static variables, how we can use static variables and methods. Then later we will see about the instance variable and instance method. So here I want to create a static variables first one. So I want to create a static variable first. I'm taking as variable name as L. That's static variable name is L. First variable L. I'm taking as type as a double. This is my variable name double. Then next variable I want to create as B, and this also considered double. And next parameter is H. It also considered as double. And these all the variables are I'm going to taking as a static variables. So static variables are all I have to use as underline. So I'm taking every variable as underline variable. This is static variables. Because in class diagram we can represent all static variables in underline only. So these are static variables. Now this here I'm going to take as only class level, method level modularization. So only single class will be available. So I want to use the access specifiers. So there are three different kind of access specifier you can use here. One is private. The four kind of access specifier: private, default, protected, and as well as public. First you have to know what is private. Private means all the members and methods can be accessed only within classes. Outside the classes we cannot access. If you take a default, the members method can be accessed only throughout the packages. So within the package any class can access. If I'm taking as a default, that is next level. Within the package or different packages only child class can access. If you given as public, any class, any package can access your members. So here I'm going to follow as only as method level modularization. So I have only one single classes. So I want to mention everything as private. So we can represent private symbol as minus in class diagram. So here I want to use a minus symbol for private members. So this is all I'm going to add as minus. So now all three instance members are added. That is all the variables are added here. Then later I want to add the methods. So I have a method as here find volume. This find volume also private variables. Let's take one find volume. This is a method, and this method always returning as double parameter. Let's take as double. Method name is double. This one is returning as double values. Then I want to add the main method here. So I'm adding as main method. Main is a static method, and we have a parameters args parameter. Actually this one is a string, and which is written as void. So this is your class diagram about the method level modularization. Method level modularization. This is one. This simple design you want to implement now in Eclipse. You see here. So I have one class name cuboid with three instance member, that is static variables, LBH value as a double, and there is one simple method find volume. This is also static method, and one more method is called main method. Now we have to know this one static method rules. A static method can access only static variables and can invoke other static methods. That's simple rule. A static method can access only static variable, or it can invoke only other static methods. So here find volume is a static method. It can access LBH values, and main method also static method. It also can invoke the find value methods. So here all the methods are static. You can represent the static in class diagram by using underline. Now this simple design we have to implement in the class diagram. Same class diagram I want to implement in Eclipse. So I'm going to take a package name here P1. So package P1 I want to create a class name as a cuboid. So I want to create the class name here. Let's take a class name as a cuboid. So the class contains main method. So I'm going to implement with main also here. Now class was loaded. Now we have to add all our members. So here all the members are private members, private, and as well as static variable, static, and the type is double L comma B comma H. And we have one instance method here, that is a static method as well as find volume. So there are also private method, private, and it is static method, and the return type is double, and method name is find volume. So it is a return method, so we can write return values, return 0. So later we can fill the methods. Now we have to go to this main method, because compiler always execute with only main method here. Now this main method want to access the L value, B value, and H values as well as find volume method. So here we can take either input as runtime input, or we can take as compile time input. If you want to take a runtime inputs, I want to add the scanner class. So I want to create scanner class object. I'm taking a scanner class object in SC. So I want to create a scanner class object. Then I want to close my scanner classes. So scanner class is, that is, at last you have to close the scanner class object. Now we want to initialize the values here. So L value, B value, H value, these are all static variables. Main method also static method. So this method can access all the static variables directly within the classes. Very simple. A static method can access all the static variables and static methods directly only within the classes. So I can access directly L value in the here. So I can write inputs here next double. So L is a double parameter, I can give next double. And B also double parameters, we can give us next double. Then H values, next double. Now all the variables are initialized values by using runtime inputs. Then I want to call the method as find volume method. So first I'm writing this one, I've got println plus volume equal to, I want to write a method, I want to call the method, this one is, I can write directly here, find volume. You see here, the main method is a static method, it can invoke other static methods. So directly I can call this other static method within the classes. So find volume also static method, directly I can invoke the static methods. Now this main method is calling a find volume method. Now this method is getting invoked. Now we want to return the values of cuboid. That the volume method only value are returned. That's L into B into H. So this find volume method is returning as L into B into H, and finally the value is printed in the main method. Now let's execute this program. So I want to execute. If you want to enter the message, you can enter here, or directly you can provide our inputs here. I want to enter the L values, B value, H value. First I'm giving L value 10, 11, and 12. So I'm printing volume as 1320. So this simple program is called as method level modularization. Method level modularization. The same class I'm going to implement the different methods. Main method as well as find value method also is there. And all the methods are members I'm taking as static variables. If I'm having static variables, a method can access, a static method can access only static variable, and it can invoke only other static method. That is important rule you must remember. Thank you for watching. We'll see the class diagram also. Thank you.